Okay, let's continue. Chapter 2 is on linear equations. So we can ask, what is a linear combination? So consider rational variables x1 through xn and rational numbers a1 through an. An expression of the form a1 x1, I'll write it in the next line. An expression of the form a1 x1 plus so on plus an xn is called a linear combination of variables x1 through xn. So expressions of the form a1 x1 plus so on till an xn, sums of this form are called linear combinations. So for example, 3x plus half y is a linear combination of variables xy. Consider variables x1 through xn and numbers a1 through an. An expression of the form a1 x1 plus so on till an xn is called a linear combination of variables x1 through xn. Okay. For example, 3x plus half y is a linear combination of variables x and y. We can ask, can we solve systems of linear equations? So for example, suppose we are given two equations, 2x plus y equals 1 and 3x minus 2y equals 4. So can we solve for x and y? So let's see. So 2x plus y equals 1 and 3x minus 2y equals 4. So multiplying the first equation by half, we get x plus half y, so it becomes 1x plus half y equals 1 by 2 and 3x minus 2y equals 4. So we multiplied the first equation by half so that the coefficient of x in the first equation becomes 1. So now that the coefficient of x in the first equation is 1, we'll use this 1. So now doing second equation, changing second equation to second equation minus 3 times first equation, we have 1x plus half y equals half, and so second equation minus 3 times first equation changes the second equation to 0x. So we change the 3 to a 0, and plus, let's see, minus 2 minus 3 by 2, right? Minus 3 by 2 y equals 4 minus 3 by 2. That is 1x plus half y equals half, and minus 4 minus 7 by 2 y equals, so 8 by 2 minus 3 by 2, this is 5 by 2. That is x equals half minus half of y, and y is equal to minus 5 by 7. That is x equals half minus half of minus 5 by 7 equals 7 by 14 plus 5 by 14 equals 12 by 14. 2 6 are 12, 2 7s are 14, and y is equal to minus 5 by 7. That is, maybe I'll write, it's fine. That is, x is equal to 6 by 7, y is equal to minus 5 by 7. So what did we do? We looked at the system of equations. 2x plus y equals 1, 3x minus 2y equals 4. We changed the 2 to a 1, the first coefficient 2 to a 1, by dividing first equation by half. Then we used that 1 to remove the 3x in the bottom. So second equation minus 3 times first equation gave. So doing this won't change the first equation. The first equation will remain 1x plus half y equals half. The second equation will change to, that x will get eliminated. The second equation will change to 0x plus minus 2 minus 3 by 2y equals 4 minus 3 by 2. So we get these two relations between x and y. Hence, finally we get x equals 6 by 7 and y equals minus 5 by 7. Right. So we have solved this system of equations. We can ask, does a system of linear equations always have a solution? So the answer is no. For example, the system 2x minus y equals 5, some linear combination of x, y equals 5, and the same linear combination equals 7. This system has no solutions. You cannot find x, y such that 2x minus 5 is both 5 and 7 at the same time. Hence, the system has no solutions. So a system of linear equations need not always have a solution. So we have studied solving two linear equations in two variables. So the general procedure is clear from the above example. So we studied solving two linear equations in two variables. We can ask, can we solve three linear equations in three variables? So Suppose we are given a system of three equations: 3x plus 2y plus 4z equals 1, minus x plus y plus 2z equals 2, and x minus 3y plus z equals minus 1. Can we solve for x, y, z? So let's see if we can use the same technique. So we have 3x plus 2y plus 4z equals 1, minus x plus y plus 2z equals 2, and here we have 1x minus 3y plus z equals minus 1. So first we'll put the 1x equation at the top. Putting the 1x equation to the top, so we get 1x minus 3y plus z equals minus 1, and 3x plus 2y plus 4z equals 1, and minus x plus y plus 2z equals 2. Now we can use this 1x, this coefficient 1, to eliminate the x variables in the other two equations. So doing second equation, changing second equation to minus 3 times first equation, and third equation, we changing third equation to third equation plus the 1 times the first equation, we have, so the first equation will remain the same, 1x minus 3y plus z equals minus 1. In the second equation minus 3 times first equation, we are subtracting 3 times the first equation from the second equation. So I'll write, that is subtracting 3 times first equation from second equation. In words, this is what it means. So it's fine, it's understood. Even this notation is clear. So after changing second equation to second equation minus 3 times first equation, what we'll get is 0x, what we'll get is 0x. Crucially, this 3x becomes 0x, and the other terms we'll look at them. 2 minus 3 times minus 3. So 2 plus 9, 11, right? So you get 11y plus second equation minus 3 times first equation, 4z minus 3z. So you get z, and the right hand side becomes 1 minus 3 times minus 1. So you get 4. Similarly, the third equation becomes 0x plus minus 2y plus 3z equals 1. That is, so we get 1x, or I'll not write 1x now. Our job with 1x is over. X plus minus 3y plus z equals minus 1. Now we get 11y plus z equals 4, and minus 2y plus 3z equals 1. Now we can focus on the 11. The strategy is, we now solve the last two equations. So these two equations are two linear equations in two unknowns, in two variables. we can solve these two in the usual way. To get y and z, and then use first equation to get x. So the last two equations after this transformation, they become two linear equations in two variables. So we can solve these in the usual way to get the two variables y and z, and then using the first equation we can get x. So we'll finally get all three variables x, y and z. So solving the last two equations is our goal. So we have highlighted 11 here. We'll first change this 11 to a 1. So doing second equation to 1 by 11 times second equation, we have, so the first equation will remain the same, x plus minus 3y plus z equals minus 1. First equation will become 1 times y plus 1 by 11 times z equals 4 by 11, and the third equation will remain the same, minus 2y plus 3z equals 1. So now we'll use this 1 to get rid of the minus 2 here. Okay, I'll underline minus 3x and minus x. In the first step, we used the 1x to eliminate the 3x and minus x terms in the other two equations. Now we are using this 11, change this 11 to a 1, 11y to a 1y, and using this 1 to eliminate y in the third equation. So doing third equation to third equation plus 2 times second equation, we have, so the first equation will remain the same, x plus minus 3y plus z equals minus 1. This 1y, so we have 1y plus 1 by 11 z equals 4 by 11, or I'll not emphasize the 1 here now because we have used the 1. Now this becomes, or I'll write it again, 0 times y. So we have changed the minus 2 to a 0 plus 3 plus 2 by 11 z, right? So 3 plus 2 by 11 equals 1 plus 8 by 11. That is x plus minus 3y plus z equals minus 1. So y plus z, so 1 by 11 z equals 4 by 11, and so 33 by 11, so 35 by 11 z equals 11 by 11 plus 8 by 11, 19 by 11. Hence, so from last two equations we get y and z. Hence x plus minus 3y plus z equals minus 1, and y equals 4 by 11 minus 1 by 11 times z. Z is 19 by 35 from the last equation, by 35. So this is 35 into 4 is 140. So 140 by 35 into 11 minus 19 by 35 into 11. 140 minus 19 by 35 into 11 equals, so I'll write it again, that is, so x plus minus 3y plus z equals minus 1, y equals, so This is 121 by 35 into 11. So 11s are 121. So you get 11 by 35. Y is 11 by 35. Z is 19 by 35. Hence x equals -1. So let's write here x equals -1 plus 3 times 11 by 35 plus minus 19 by 35. So x equals -1 plus 3y minus z, right? So y equals 11 by 35. Z equals 19 by 35. That is x equals, so over all take 35 common, here itself we can do it, take 35 common, so minus 35 plus 33 minus 19, so minus 21 by 35, right? Y equals 11 by 35 and z equals 19 by 35. So these are the values of x, y and z. We have solved for x, y and z. What did we do? The strategy was simple. We first took advantage of the 1x equation and used that to eliminate the other x terms from the other two equations. Then we solved the other two equations for y and z. So for solving the other two equations, we used 11y term we changed it to, so where is the laser pointer? We got 11y term in the second equation. This 11y term we changed it to 1y term by multiplying by 1 by 11. Then we used this 1y term to eliminate the minus 2y term from the third equation. So we got a system of this form. Now it is simple. From this system, from the last equation, we immediately get z, and from the second equation, we get y value, and from the third equation, we substituting y and z values, we get x value. So we got y value, we got z value, hence x becomes this, y becomes this, z is this. That is x is minus 21 by 35, y is 11 by 35, and z is 19 by 35. So in general, this is the approach for solving any system of linear equations. We make use of 1x like term. We create a 1x equation and use that equation to eliminate x's from the other equations. Then we create a 1y equation and use the y equation to use the 1y term to equation to eliminate the y term from the rest of the equations, and so on. So we get a system like this. So this is called a triangular system in general, but in any case, we get a system like this, and with this we can just find out the x, y and z immediately. So right, so that's all for this part. See you in the next part.